Hey guys, so today we're going to do lesson 15 and it's solving by elimination. So we're going to look at a couple of different ways to use elimination, and it's just our third method of how we can solve a system of equations. So for this first equation we have, for the first system, we've got 4x plus 3y equals 10 and negative 4x plus 5y equals 6. So there are 3 steps here, just like there were with substitution. All right, so the first thing that we're going to do, we want to make sure that our like terms are lined up. So you can see that we have x's, so 4x and negative 4x, they're on top of each other, they're lined up. And then we have y's lined up, and 10 and 6 are our constants. So we have x's, y's, and constants. Now this could be in a different order. We could have y's and then x's and then constants, or we could have them switched around in any order as long as they're the same for both equations. So once those are lined up, we have to decide how we can combine these. So here's a shortcut that helps us with elimination. Since we know that a system of equations, the solution is the point where the 2 lines intersect. So one point is going to be the same for both lines. So we can find that if we can cancel out a variable. So since the x value, so the coefficient there is 4, and then the second equation is negative 4. So if I combine these equations by adding, I'm going to maintain equality, but I'll also cancel out that x so that we can find y. So I want to add these equations. So I get 4x plus negative 4x. That cancels out, so they're gone. And then 3y plus 5y is 8y, and 10 plus 6 is 16. So then I can just solve for y and then go to step 2. So to get y by itself, I'm going to divide both sides by 8. 8 divided by 8 is 1, so I'm just left with y. And 16 divided by 8 is 2. So now I know that y is 2. I can go on to step 2. So my step 2, I'm going to take this 2 and plug it into either one of these equations. It doesn't matter which one you use because you're going to get the same answer either way. So I'm going to use the top one since x and y are both positive there. So I have 4x plus 3y equals 10. And in place of y, I'm going to put 2. So I have 4x plus 3 times 2 equals 10. And from here, I'm just going to use my order of operations and inverse properties to get x by itself. 3 times 2 is 6 equals 10. Subtract 6 from both sides. Bring down the 4x. 6 minus 6 cancel out. 10 minus 6 is 4. Then divide both sides by 4 to get x alone. And 4 divided by 4 is 1. So I know that x equals 1. Step 3 is the same as it was in substitution. We just write our answer as an ordered pair. So x comma y, 1 comma 2. All right. So this is just a little quicker way to find the solution if our equations are set up correctly. All right. So let's look at another one. Here we have 2x plus y equals 4 and x minus y equals 11. So now our x's aren't going to cancel out because they don't have the same coefficient. But for the y's, I have a 1y and a negative 1y. So if I add these 2 equations together, they will cancel out for me. So 2x plus x gives me 3x. 1 plus negative 1y cancel out, so I no longer have a y. And then 4 plus 11 is 15. Now I can just solve for x. So I divide both sides by 3, and x equals 5. So then I can go on to step 2. So for step 2, I'm going to replace either one of these equations. I'm going to use the top one because it's both values are positive there. So 2x plus y equals 4. So instead of x, I'm going to put 5. All right, 2 times 5 is 10, plus y equals 4. Subtract 10 from both sides. Bring down the y. 10 minus 10 cancel out. And 4 minus 10 is negative 6. And then the last step is just to write your answer as an ordered pair. Okay, so I have 5 comma negative 6 as my solution. Just realized that's in the way. All right, so let's try another one. So I want you to try to see if you can do this one. If we add these, will we cancel out any of the variables? So go ahead and try that on your own. All right, so for our step one here, it's a little different. If I were to add these equations, my x value has the same coefficient, but if I add them, I'm not canceling it out. I'll have 16, so that doesn't help. So since they are exactly the same, I'm going to subtract these equations. So I have 8x minus 8x, and that cancels out. And then I have 11 minus 1, gives me 10y, and 37 minus 7 is 30. So from there, I can divide both sides by 10, and y equals 3. All right, and then moving on to step 2, I'm going to plug the answer into the equation, not the equation. So I'm going to plug y, which is the answer. Didn't read that a minute ago. Sorry. So I have, it doesn't matter which one we choose, but looking here, we've got 8x plus 11 or 8x plus 1. So the second equation would be easier for us to solve for x. So let's use it. 8x plus y equals 7. And so in place of y, I'm going to put 3. Okay. And now I can just solve for x. So I'm going to subtract 3 from both sides. Bring down the 8x. 3 minus 3 cancel out. 7 minus 3 is 4. And divide both sides by 8. Oops. Didn't mean to draw that whole line there. 8 divided by 8 is 1x, and 4 divided by 8 gives me 1/2. So our solution here is 1/2 comma 3 for step 3. All right, so we always write our answer as an ordered pair because we're talking about that point on a graph where the two lines cross. All right, and we've got one more to look at. This one, we put a fraction in there. Fractions are just numbers too. Don't get afraid of them. So go ahead and see what your step 1 might be here. All right, so looking here, our x's are not the same. They are lined up. Our y's are lined up, and they are the same value. They're both 1/2. One is positive, one is negative. So that tells me that I can add these two equations together to cancel one out. So 2x plus 6x gives me 8x. 1/2 plus negative 1/2 cancel out. So I no longer have a y value. And then 7 plus 5 is 12. So from here, I can just divide both sides by 8. 8 divided by 8 is 1x. 12 divided by 8 is 3/2, or 1.5. You might have gotten that. So then I'm going to go on to step 2, and I'm going to plug that in. So it doesn't matter which equation you use. I'm going to use the one that has a positive 1/2. So 2x plus 1/2 y equals 7. So instead of x, I'm going to put 3/2. So I have 2 times 3/2 plus 1/2 y equals 7. And from here, we're just solving like normal. 3 times 3/2, or 2 times 3 over 2 is 3 plus 1/2 y equals 7. And then subtract 3 from both sides. And you're left with, I'm going to go up here, 1/2 y equals 7 minus 3 is 4. Divide by 1/2 on both sides. That cancels out. and y equals 8. So for step 3 here, we have 3/2, comma 8. All right, so hopefully this helps you out. If you're still struggling with some substitution problems, you can email me for help on those. Basically, when you substitute part of that equation in, you're still solving for that variable, and you're just going to solve it like normal, like you would a two-step equation. And it also gives you an answer as an ordered pair. Okay? So if you're struggling on your practice problem, if it asks for the solution, it wants you to write your answer as an ordered pair unless it explicitly asks for the x value or the y value. The solution is going to be an ordered pair. All right. So I want you to try these on your own, and we'll go over those in our next video. And when you get to this one, I want you to pay attention to how this fourth one is different from the other ones.